You probably already know that Tailscale makes direct device-to-device connections wherever possible using our NAT traversal technology, but sometimes that just isn't possible. Now, the reasons for this are wide-ranging, and they usually don't have a whole heap to do with Tailscale itself, and much more to do with the network conditions that you are connecting through. Now, if you're curious to learn more about how NAT traversal actually works, I'll link to a detailed blog post on the Tailscale blog down below. Tailscale has a solution for when you can't establish a direct connection already, and that's our relay network called DERP servers, D-E-R-P. And while DERP servers are very effective at relaying traffic, they're a free shared resource used by all Tailscale users. They introduce extra latency, and they can be a bit slow sometimes. This led us to ask the question, how do I maintain a performant connection to my infrastructure via Tailscale when I can't establish a direct connection, and do so without relying on the shared public relay infrastructure? Well, peer relays are the answer and the subject of today's video. I'm delighted to tell you that Tailscale peer relays are now generally available. Peer relays let you use your devices, the ones that are already on your own Tailscale network, as high throughput relay servers. You can think of it a little bit like self-hosted DERP servers, although they are different in how they work. Peer relays really shine when direct connections aren't possible due to network conditions like strict NAT, symmetric NAT, carrier grade NAT, all those sorts of things. And in today's video, I'm going to show you just how useful peer relays can be. Now, before I get too much further into the video, I need to tell you that Tailscale Up, our user conference, is returning in August of this year. Tickets are now on sale, and there'll be a link in the description down below. This is the conference for engineering, security, and IT leaders shaping the future of secure connectivity. And we have early bird pricing right now, so you can get $200 off now through March 31st. Have a look in the description down below for a link to get your ticket today. Now, the reasons that NAT traversal can fail are legion, but the most common reasons that these direct connections fail are things like carrier grade NAT, symmetric NAT, and restrictive corporate firewalls. Now, with carrier grade NAT, or CG NAT for short, your ISP puts thousands of users behind a single shared public IP address, or a small batch of public IP addresses, so that you're actually behind multiple layers of network address translation, and you don't control how the ports are mapped or how long those port mappings stay open. NAT traversal relies on being able to manipulate some of the stateful firewall things that happen. Again, if you look at the how NAT traversal works blog post, you'll learn a lot more about that. So carrier grade NAT is bad, but symmetric NAT is even worse. Symmetric NAT assigns a different external port for every destination that you talk to, which completely breaks the UDP hole punching mechanism that our NAT traversal technology uses. The ports that you learn during discovery simply don't work when peers try and talk back and forth to each other between those stateful firewalls. So carrier grade NAT is bad, symmetric NAT is bad, and then there are things like corporate networks, hotel Wi-Fi, public hotspots. None of these things really are they're a pretty hostile set of network conditions. These types of places aggressively filter UDP and expire their port mappings quickly, sometimes so quickly that we can't establish just in a couple of seconds the mapping between the two ends of the tunnel that we make to establish a direct connection. So in all of these cases, Tailscale will still work, but direct connections just aren't ever established. And so typically you would fall back to our DERP servers, our relay servers, and proxy all of your traffic, encrypted end-to-end, I might add, but you'd still proxy all of that traffic through those shared public resources of the Tailscale DERP relay network. DERP is designed to be universally reachable and reliable, but it's a shared infrastructure, as I say, which Tailscale provides for free, by the way, to every single Tailscale user, on the personal plans right the way up to our enterprise customers. Everybody gets DERP for free. Now, DERP, because it's a shared resource, is optimized for availability and fairness, not maximum throughput. So things like streaming video, file transfers, anything that needs a lot of bandwidth continuously, it's just not going to be a good time through the DERP server. You'll make the connection, but as you'll see in this blog post from a colleague of mine, Raj, in our solutions engineering team, when he went to India for the holidays just a month or so ago, connecting back from India to his home lab in the United States. The connections there were just really slow and restricted for all sorts of reasons. So check out that blog post down below if you want to learn more about a real world kind of home lab use case for peer relays. Peer relays, as I say, they give you another option from the DERP network. They're not designed to completely replace the DERP network. They're designed to augment the DERP network. Peer relays let you designate a node in your own tailnet as a high throughput relay. So in other words, when direct connections fail, the traffic flows through that high throughput peer relay instead of through a shared DERP node. Traffic stays end-to-end encrypted and in memory on the peer relay, which never decrypts anything. It just forwards the packets between the authenticated Tailscale peers. Now just take a look at this. This is what I'm calling standard node, a plain, boring Tailscale node with a direct connection established from my laptop here in Raleigh up to AWS. This is an EC2 instance. So I can do Tailscale ping standard node. And we know that a direct connection has been established because we get this. It doesn't say via DERP. It's just a direct connection. Indeed, if we do Tailscale status, we can see also the state of the connections to all of the different nodes on my tailnet. And we can see direct. That's how you know you've established a direct connection. So we're going to get the best performance to this node right here. And you can see standard node just running a Libre speed test out of a container on this node just for fun. I'm getting 800-900 megabytes as a direct connection over Tailscale to this node. You can see that this is just a node on my tailnet. Now, I have another node here, which is behind a restricted NAT environment, and I cannot establish a direct connection. In fact, if you see if I do Tailscale ping to restricted node, you can see that instead of establishing a direct connection like Tailscale ordinarily would, I'm having to ping through the DERP server in IAD in Washington. Now, this is a problem for performance. Look at the difference here. We get 38 megabytes instead of 968. These two VMs are both running in EC2 in the same network conditions. I've just enabled a debug flag on the restricted node to force it to never establish that direct connection. So we can see here the performance delta between a direct connection and a relayed connection, a DERP relayed connection, I should clarify, is pretty vast. So what we want to do is create a peer relay node to access the restricted node via a peer relay. And that's how you would think about how the traffic flows. It goes from laptop to peer relay and out to restricted node. So all the traffic traverses that peer relay node. So any bandwidth overages and that kind of stuff, you've got to be cognizant of where you architect these things. In a home lab scenario, for example, you could put your peer relay into a DMZ and then use your home ISP and your home bandwidth, assuming you have good enough internet connection, to make this more performant. Okay, so how do we set up a peer relay? Well, a peer relay really is just another node on your tailnet. And I happen to have a node here called relay node. And we're going to set this one up today. Again, this is just running in EC2 alongside the other nodes. We're going to set this up to be the peer relay on our tailnets. So we're going to do tailscale set -- relay server port equals 40,000. Now, this port 40,000 must be effectively on the public internet. This is a UDP port. I should also point out that peer relays by design, the port is not open in the traditional sense or unauthenticated. It's in fact completely silent until relay participants prove their identities cryptographically. So if you're nervous about opening a port, on this one occasion, you don't probably need to be. So essentially what we need to do is either port forward in our firewall, port 40,000 UDP to this node, or in Amazon, we need to open the security group to this node to allow port 40,000 UDP to reach this node. So if I do tailscale set relay server port equals 40,000, the next thing I need to do is jump into the AWS console. And in AWS, we need to go into the security group for the relay node. And we need to ensure that port 40,000 is pointed or allowed through the firewall or the security group in AWS. You can see right now, it currently isn't. So we go into the security group right here. Again, this is just launch. This is basic stuff, right? I know for Amazon people, but basic stuff. We're going to edit the inbound rule, and we're going to add one here of custom UDP port 40,000. And well, what I'm going to do actually in the background is I'm going to start Tailscale ping C0, Tailscale ping C0 to restricted node. Because what I want you to see happen in real time is for the relay to start working. We've got a couple of grants and ACLs to do as well before this will actually start working, but just bear with me. All right, so we're going to save the rule here, port 40,000, save the rule. Oh, cider block. Yes, source everywhere is fine. The UDP traffic is now allowed to hit the relay node from the public internet. And this is enough for it to establish a relay server connection behind the scenes. So you can now see that instead of going through the DERP infrastructure, we're now going through the peer relay instead, which is, as I say, just another EC2 virtual machine. So same website. I'm going to load up the speed test again, Libre speed. And this is now going to route the packets through the peer relay. And let's see what difference that makes to performance. There you go. So just by enabling a peer relay, we have 15x our performance at minimum, maybe more. So obviously you're restricted by the performance of the peer relay node itself, but a lot of this stuff happens in memory. So, you know, it should be pretty fast. There are a couple more steps that you're going to need to follow in order to get this actually working. I did this before we started recording, just in the interests of time, but you're going to want to create a couple of tags. In my case, I've got US East 1 and US East 1 relay. So I will tag the nodes that I want to act as the peer relay as the relay. And let me show you that here. So relay node is tagged as a relay. And then this grant basically tells Tailscale to use that node as a relay for the targets listed behind it. So in my case, let's find the rule right here. This is an application grant. You can see that any node that is either an auto group member, so that's nodes that I own as my Tailscale default user, or are tagged with tag US East 1, will route effectively, will relay through that node. Now what's fun is I want to show you that I'm going to ping the restricted node, and then alongside it, I'm going to power off the relay node. So let's go into relay node, and I'm just going to power it off. And I want to show you in real time how long it takes for the Tailscale network to kind of heal and come back to life. You can see the pings have stopped. They started timing out. And so now we're going to fall back from the relay node to the DERP infrastructure. Voila. Don't you love it when a demo just works like that? So really, it shows you that even if your relay infrastructure isn't as resilient as perhaps it should be, the DERP relay network still has your back. Now, a common question I see is whether you can run a peer relay at home. And as Raj pointed out in the blog post I talked about earlier, yes, you can. You can put the peer relay in a DMZ and then use your home internet connection as a sort of private relay for just your tailnet. This might be really useful for those of you that run a Jellyfin server, for example, and want to guarantee that your friends and family always have a direct connection to your server so that they can stream the bits and bytes at the maximum speed that your ISP's bandwidth permits. And so there we are. Peer relays are now generally available. They don't replace DERP, they just complement it really nicely, in my opinion. Because when direct connections fail, you can sometimes be sat here staring at this via DERP screen wishing, why isn't it faster? Even though, of course, the DERP is a free shared resource amongst all tailnets. The peer relay infrastructure gives you a way to regain performance using infrastructure that you already control. Now, don't forget to get your ticket for Tailscale up. I'll put a link in the description down below. And as always, thank you so much for watching. Until next time, I've been Alex from Tailscale.